Hello everyone, this is Siddiqur Rahman and welcome to the first lecture of the 6th week. So let's start with the learning objective. By the end of this lecture, students will able to know about the overview of multiplexer. From this slide, you guys will able to know what topics or how many topics will cover by this lecture. You guys will know about this lecture, or you guys will know from this lecture various things, such as first you need to know, or you would like to know the general overview of this lecture, or you can say the multiplexer. After that you will know the overview of multiplexing, types of multiplexing techniques, brief overview of FDM, WDM and TDM, overview of multiplexer, basic idea of multiplexing, block diagram of multiplexer, and so on. So let's start with the general overview of this lecture. Multiplexing is the property of combining one or more signals and transmitting on a single channel. This is achieved by the device multiplexer. A multiplexer is the most frequently used combinational circuits and important building block in many in-digital systems. These are mostly used to form a selected path between multiple sources and a single destination. A basic multiplexer has various data input lines and a single output line. These are found in many digital system applications such as data selection and data routing, logic function generators, digital counters with multiplexed displays, telephone network, communication system, waveform generators, etc. Now, a question may arise from the previous slide in your mind, which is what is multiplexing as well as what is multiplexer. So let's start the overview of multiplexing. Multiplexing, or you can say, or in short, it is called or it is known muxing, can be defined as it is a way of transmitting various signals over a media or single line. A common kind of multiplexing merges a number of low-speed signals to send over an only high-speed link, or it is used to transmit a medium as well as its link with the number of devices. It provides both privacy and efficiency. The entire process can be done using a device, namely, or you can say called multiplexer, or in short, it is called MUX. And the main function of this device is to unite n number of input lines for generating a single output line. Thus, MUX has many inputs and single output. From this slide, we may learn the conceptual figure, or we may see conceptual figure of multiplexing. And as we have already learned from the previous slide, that multiplexing occurred by a device which is called multiplexer. And in this figure, we see in the left side we find some of the input signals, and in the right side we get some of the output signals, and in the middle portion there is a channel which is called communication channel, and this is a totally represented, or you can say this is the representation of conceptual or concept of multiplexing technique. So let's move into the next slide. Now from this slide we may learn the types of The types of multiplexing techniques. So let's start. Multiplexing techniques are mainly used in communication, and these are classified into three types, such as number one, frequency division multiplexing, which is in short or which is also known as FDM. Next one, wavelength division multiplexing, which is in short or also known as WDM. And the last one is time division multiplexing, which is in short or also known as TDM. So let's start with the frequency division multiplexing. The FDM, which is elaborately called frequency division multiplexing, and which is used in telephone companies in the 20th century in long distance connection for multiplexing number of voice signals using a system like a coaxial cable. For small distances, low cost cables were utilized for different systems such as Bell systems, K and N carrier. However, they don't let huge bandwidths. This is analog multiplexing used to unite analog signals. This type of multiplexing is useful when the link's bandwidth is better than the united bandwidth of the transmitted signals. From this slide, we may learn the overview of WDM, which is elaborately called wavelength division multiplexing. So let's start. In fiber communications, the wavelength division multiplexing is one type of technology. This is the most useful concept in high capacity communication systems. At the end of the transmitter section, the multiplexer is used to combine the signals, as well as at the end of the receiver section, demultiplexer for dividing the signals separately. Well, the main function of wavelength division multiplexing at the multiplexer is for uniting various light sources into an only light source, and this light can be changed into numerous light sources at the demultiplexer. From this slide, we may learn the time. I repeat it again. From this slide, we may learn the overview of time division multiplexing. So let's start. The TDM, which is elaborately called time division multiplexing, is one kind of method for transmitting a signal over a channel of particular communication with separating the time edge into slots. Like single slot is used for each message signal, TDM is mainly useful for analog and digital signals, in which several channels with low speed are multiplexed into high speed channels used for transmission. Depending on the time, every low speed channel will be assigned to an exact position. Wherever it works in the mode of synchronized, both the ends of marks and demarks are synchronized timely, and at the same time the switch toward the next channel. Now, time to come to learn the overview of multiplexer. So let's start. Multiplexing is the generic term used to describe the operation of sending one or more analog or digital signals over a common transmission line at different times or speeds. And as such, the device is used to do just that is called a multiplexer. The multiplexer, or shortly known as MUX or MPX, sometimes it is called MPX, is a digital switch, also called as data selector. Sorry, I repeat it again. Also called as data selector. It is a combinational circuit with more than one input line and one output line, and also more than one select line. It allows the binary information from several input lines or sources, and depending on the set of select lines, particular input line is routed onto a single output line. In another way, we can say the multiplexer is a combinational logic circuit designed to switch one of several input lines through a single common output line by the application of a control signal. Multiplexers operate like very fast acting multiple position rotary switches connecting or controlling multiple input lines called channels, one at a time, to the output. The basic idea of multiplexing is shown in the following figure, in which data from several sources are routed to the single output line when the enable switch is on, which means the circuit is connected or circuit is closed. Well, that is why the multiplexers are also called as many to one combinational circuit, and figure 2 represents the basic concept of multiplexing. Well, if you see the middle portion of this figure, then you may find two alphabet. One is alphabet A and another alphabet is B. And after below the alphabet B, you can find a word which is enable switch. If you think about in this way, if you want to enlight your home, if sorry, I repeat it again, if you enlight your home, your room light, or you can you would like to turn on the light of your room, then you need to switch on, otherwise it doesn't on. Okay, so in here, if the point A is connected with point B, in that case the circuit is completed. In that case, you can find in the output section the source 1, because this is connected through the system. In this way, rest of the sources, if in this way the rest of the sources are connected, will be connected, and found it in the output section. So let's move into the next slide. Now from this slide we may learn the block diagram of multiplexer. So let's start. The block diagram of a multiplexer consisting, I'm really sorry, I repeat it again. The block diagram of a multiplexer consisting of n number of input lines, m number of selection lines, and one output line. If there are m selection lines, then the number of possible input lines is 2 to the power m. In other words, we can say that if the number of input lines is equal to 2 to the power m, then m number of selection lines are required to select one of the n input lines. And figure 3 represent the block diagram of, or you can say the general block diagram of a multiplexer. So in the block, if you see or if you look at the block diagram, then you will find three sections. One is left section, another one is middle section, and another one is right section. In the left section, or in this block diagram, in the left section you may find the number of input signals, which is symbolized by small letter n. And in the middle section you may find, and middle and also as well as the bottom section of the rectangular box, you may find number of select lines, which is symbolized by m. And in the right section you may find number of output signal, which is only 1, because we are studied multiplexer, and we have already known that in multiplexer there are more number of inputs than output, and that's why we called multiplexer as many to one combinational circuit. So let's move into the next slide. Now, now time to come to design 2-to-1 multiplexer. So let's start, and first step would be inputs and outputs declaration. Well, a 2-to-1 multiplexer consists of two inputs which is symbolized as D0 and D1 respectively, one select input which is symbolized by capital letter S, and one output which is symbolized by capital letter Y. Depends on the select signal, the output is connected to either of the inputs. Since there are two input signals, only two ways are possible to connect the inputs to the outputs. So one select is needed to do these operations. Well, if the select line is low, then the output will be switched to D0 input. Remember these things carefully. I repeat it again for you guys. If the select line is low, then the output will be switched to D0 input. Whereas if the select line is high, in that case, the output will be switched to D1 input. So let's move into the next step. Now, second step would be draw the block diagram of 2-to-1 multiplexer. The following figure shows the block diagram of a 2-to-1 multiplexer which connects two 1 inputs to a common destination, which means 2-to-1 multiplexer has two inputs and one outputs and also one select lines. And if you figure 4 represent the block diagram of 2-to-1 multiplexer, and in the left side you find two things. One is inputs and another one is another special type of inputs which is named as enable and symbolized by capital E, and the general inputs are symbolized by D0 and D1, and in the middle section, which means the bottom part of the rectangular box, or you can say the square box, you may find one select line which is symbolized by capital letter S, and in the right section you may find the output which is symbolized by Y. So let's move into the next part. Now, third part would be the truth table of 2-to-1 multiplexer. The truth table of 2-to-1 multiplexer is shown in below, and this truth table has three sections. One is select section, another one is inputs section, and the last section is the output. And we have already known that 2-to-1 multiplexer has one select line. That's why we may assign just two numbers. One is 0 and another one is 1. Now come to the middle section, or you can say the input section, which is symbolized by D0 and D1. Since the number of inputs are 2, that's why we may assign two binary number. One is 0 and 1, and if we combine these two numbers, then we get 4 combinations, which are 0 0 0 1 1 0 and 1 1. And now come to the right section, which is named as output section and which is symbolized by capital Y. And in that case we find just either 0 or 1. Now let's see what gives this truth table to us. First, when the select line is 0, then the combination of inputs are 0 0. In that case we may find the output 0. Well, next, second combination, if we look at the second combination, then the select line is also 0. The select line is 0 like the previous stage, and we find the input combination is D0 is 1 and D1 is 0. In that case we may find the output is 1. Well, when the select line is 1, in that case the combination of inputs is D0 is 0 and D1 is 1. In that case we may find in the output section 1. And Again, if the select line is 1, in that case, the combination of the inputs are D0 is equals to 1 and D1 is equals to 1. In that case, the output will be 1. So let's move into the next step. Well, fourth step would be the Boolean function or expression of the output of 2 to 1 multiplexer, and we have already know that 2 to 1 multiplexer has one input, so the final expression, or you can say the Boolean expression, should be just 1. So let's see. Depending on the selector switching, the inputs are producing at outputs D0, D1 and are switched to the output for S select line when S is equals to 0 and when S is equals to 1, well, respectively. Thus, the Boolean expression for the output becomes D0 when S is equals to 0 and the output is D1 when S is equals to 1. From the truth table, the Boolean expression of the output is given as Y is equals to D naught S bar. Sorry, I repeat it again. Y is equals to D0 and not S or D1 and S. And if you look at the truth table, you may find there is no difficulties to write this Boolean expression. That's why I attached the truth table of 2 to 1 multiplexer in this slide. So let's move into the next slide, or you can say the next step. Well, fifth step would be the implementation of 2 to 1 multiplexer. So let's start. From the output expression, the logic circuit of 2 to 1 multiplexer can be implemented using logic gates as shown in figure. It consists of 2 AND gates, 1 NOT gate and 1 OR gate. When the select line S is equals to 0, the output of the upper AND gate is 0, but the lower AND gate is D0. Well, thus the output generated by the OR gate is equal to D0. Similarly, when S is equals to 1, the output of the lower AND gate is 0, but the output of the upper gate is D1. Therefore, the output of the OR gate is D1. Well, from this slide, we may know the logic circuit, or we may find the logic circuit diagram of 2 to 1 multiplexer. As we have already mentioned in the previous slide, that 2 to 1 multiplexer, if we want to implement 2 to 1 multiplexer, then we need 4 logic gates. First, we need 2 AND gate, and which has also 2 inputs, 1 NOT gate and 1 OR gate, and you can finally design this multiplexer, which is 2 to 1 multiplexer. So let's move into the next slide. Well, from this slide, we may learn another types, or you can say another categories of multiplexer, which is named 4 to 1 multiplexer. And from the name, we said there are 4 number of input lines and there are 2 number of select lines and just 1 output. So let's start from the first step, and first step would be inputs and outputs declaration. A 4 to 1 multiplexer consists of 4 data input lines, which is symbolized as D0, D1, D2 and D3 respectively. 2 select lines, which is symbolized as S0 and S1, and a single output line, just capital Y. Well, the select lines S1 and S2 select one of the 4 inputs. Sorry, I repeat it again. Select one of the 4 input lines to connect the output line. Well, the particular input combination on select lines selects one of input D0 through D3 to the output. Now, second step would be draw the block diagram of 4 to 1 multiplexer. The following figure shows that the block diagram of a 4 to 1 multiplexer which connects I repeat it again, which connects 4 1-bit inputs to a common destination. So figure 6 represents the block diagram of 4 to 1 multiplexer, and which has also 3 sections. One is left section, another one is middle section, and another one is right section. In the left section you may find two things. One is number of inputs, which is symbolized by D0, D1, D2, D3, and another type of or you can say another special type of input which is called or named enable, which is symbolized by E. And in the middle section you may find, or you can say the bottom portion of the middle section, you may find there are two select lines which is symbolized by S0 and S1, and in the right section you may find there is only one thing, which is only one output. So let's move into the next step. Well, third step would be truth table of 4 to 1 multiplexer. The truth table of 4 to 1 multiplexer is shown in below. Well, in this truth table we may find just two sections. One is selected lines and another one is output. Selected lines are symbolized by S0 and S1, and the output in the output section we may find just one thing, which is only one output. Well, for selection lines we assign just two binary numbers, one is 0 and another one is 1. In that case, if we combine these two numbers, then we may find four combinations. One is 0 0, one is 0 1, another one is 1 0, and another one is 1 1. Well, when the combination of selected lines is 0 and 0, in that case you may find in the output section D0. Well, next combination, if we look at the next combination, then we see when S0 is 1 and S1 is 0, in that case you may find D1 in the output section. Next, if S0 is 0 and S1 is 1, then you may find D2 in the output section, and the last combination which represents that S0 is 1 and S1 is 1, in that case we may also find in the output D3. Well, the truth table of a 4 to 1 multiplexer is shown beside, in which four input combinations 0 0, 0 1, 1 0 and 1 1 on the select lines respectively switches the inputs D0, D1, D2 and D3 to the output. That means when S1 0 and S0 is when S1 is equals to 0 and S0 is equals to 0, then the output at Y is D0, as I already said. So similarly, in this way the rest of the output are sorry, I repeat it again. Similarly, in this way you may find the rest of the outputs. So let's move into the next step. Well, fourth step would be the Boolean function or Boolean expression of the output of 4 to 1 multiplexer. Well, since 4 to 1 multiplexer has only one output, so we may find to get the total data output from the multiplexer, all these product terms are to be summed, and then the final Boolean expression of the multiplexer is given as Y is equals to D0 and not S0, not and not S1, or D1 and S0 and not S1, or D2 and not S0 and S1, or D3 and S0 and S1. And you may find there is no defect. You may find this expression from the truth table which is represented beside this. So I hope you don't have any problem regarding this issue. So let's move into the next step. Well, fifth step would be the implementation of 4 to 1 multiplexer. From the output expression of the output, sorry, I repeat it again, from the output expression of the output, A 4 to 1 multiplexer can be implemented by using basic logic gates. The figure, which is represented in the next slide, shows the logic circuit of 4 to 1 mux, which is implemented by 4 3 inputs AND gates, 2 1 input NOT gates, and 1 4 inputs OR gates. In this circuit, each data input line is connected as input to an AND gate, and 2 select lines are connected as other 2 inputs to it. The AND gate output is connected to with inputs of OR gates so as to produce the output Y. Well, this figure represents the logic circuit diagram of 4 to 1 multiplexer, and we have already mentioned in the previous slide. I repeat again. We have already mentioned in the previous slide that we have we have 7 gates, 3 inputs, 4 AND gate, 2 NOT gate, and 4 inputs, 1 OR gate. So this is the design process completed for 4 to 1 multiplexer. So let's move into the next slide. Well, from this slide we may learn some of the advantages of multiplexer. So let's start. Multiplexer makes the transmission circuit economical and less complex. Next one, analog switching current is low of order 10 milliampere to 20 milliampere. Due to such a low magnitude of the current, the heat dissipation is very low. Next one, bandwidth is used effectively. Next one, a single line is used to transmit multiple signals. Next one, it does not need K-maps and simplification. So let's move into the next slide, which is represented the disadvantages of multiplexers. Now, time to come to learn disadvantages of multiplexers. So let's start. Number 1, added delays in switching ports. Next one, limitation on which ports can be used simultaneously. Next one, extra input or output ports required to control the multiplexer. Next, added firmware complexity to handle switching ports. Next, added delays in input or output signals propagating through the multiplexer. Well, from this slide, we may learn some of the applications of multiplexer. So let's start with the number 1. Multiplexers are used in communication systems like telephone networks, satellite systems, telemetry. Next, broadcasting of radio and television signals would have been impossible without multiplexers, which is very important. Next, multiplexer is also used in data routing within the computer. For example, the address information found in a protocol header is used by the multiplexer to determine which data should be routed. Next, multiplexers are widely used in computer memory to fetch data from specified memory locations. Next, multiplexer is used as a setting comparator and function generator. You guys will learn in the next lecture the overview of demultiplexer. So that's all for this lecture. Thank you guys for your attention. See you guys in the next lecture. Till then, thank you.